Hi everyone, welcome to a new lesson. We're going to be doing something called empirical formulas. So you're going to really have to be engaged on this one. This one's a little bit harder. Of course, everything that we do in chemistry is a lot of math work. And so this one, you're going to really have to focus, okay? So empirical formulas, day one. We're going to come back to this knowing it says day one. We're going to have a day two of this. So really look at how we do this. Now, the purpose of this is to calculate the empirical formula for a compound from the molecular formula. So we're going to go back and forth from molecular to empirical. And then we're going to be able to know what's the difference. So again, looking at this, move it down a little so it looks a little better. Molecular formula versus empirical. So far, we have just discussed the molecular formula for compounds, which shows a molecule as it actually exists. But the empirical formula for a compound shows the simplest version of the compound that exists. And so when we look at this, we're going to see how to calculate that correctly. So looking at these examples real quick. Molecular shows that H2O2, and then the empirical formula, which is the simplest version of that, is HO. C2H2 is CH, NO is NO, and then N2O4. What you should notice when you're looking at this is that the empirical formula is showing this like simplified version where H2O2, if you divide by that same number, because both 2's are the same numbers, you can show the simple version of HO. But when you go down to the N2O4, what number goes into both? 2 can go into both numbers, so then N becomes by itself. And then if you do 4 divided by 2 for the O, becomes 2. So that's how we have NO2. Now we go to the next one. Determining the empirical formula. In order to find it, we have to find the largest whole number that can be divided into each of the subscripts. Remember, subscript means the number on the bottom. If no number will go into any of the subscripts evenly, then the empirical formula and the molecular formula for the compound are the same. That means you have nothing else to do. Again, same example as before. Now let's look at the first example. C2H4, what number goes into both? And I said it earlier that you would divide both numbers. What number goes into both 2 and 4? It would be 2. So then your actual answer would be C2, not C2, I'm sorry, C, H, and 2. Or you would do like 2, come on now, 2 divided by 2. And then you do 4 divided by 2. And that's how we got 2 divided by 2 is 1. And then 4 divided by 2 is 2. That's how we got CH2. Same here. Let's try this one. So if you have NO2, what number goes into both for this one? Really, this one we could just leave alone because that is the smallest one, NO2. So NO2, you're just going to leave that alone. So then the answer just stays as NO2 for this. Now, doing some practice. So if we did this one, so number 1, please watch carefully how I do it. So what number goes into both 5 and 10? We do 5 and 10 into both of them. So if you do 5 divided by 5, that would equal 1. And if you do 10 divided by 5, it would equal 2. So then your answer will come out to be CH2. All right, next one. What number will go into both for number 2? What number will go into both of them? It would be 2. 2 can go into all 3 of these numbers. All right, I will see you guys at part 2. Okay, please check out part 2.